SQL Server provides a mechanism for checking whether any results would be returned from a query. In this lesson, you'll learn how the exists predicate combines with a subquery to perform an existence test, and how to write queries that use the exists predicate in a where clause to test for the existence of qualifying rows. The exists predicate evaluates whether rows exist, but rather than returning them, it returns a true or false. This is a useful technique for validating data without incurring the overhead of retrieving and counting the results. Which means when a subquery is invoked by an outer query using the exists predicate, rather than retrieving a scalar value or a multi-valued list from the subquery, exists simply checks to see if there are any rows in the results. Conceptually, an exists predicate is equivalent to retrieving the results, counting the rows returned, and comparing the count to 0. So if there are any rows that are returned by the subquery, exists returns a true, and if there are no rows returned, exists returns a false. And this is the syntax of the exists predicate. Now let's see some examples where the exists predicate is useful. Let's open a new query, and let's say you want to retrieve all the employee information where the employee has at least one order in the sales orders table. Let's first see how to do that using the count in a subquery. Let's expand the HR employees table, and let's do a select employee ID, last name, and first name from HR.employees, and let's use a table alias E, where select count of all the orders in the sales orders table, and let's call it O, where O dot employee ID equals E dot employee ID, and the count should be greater than 0. Let's execute this query, and it will give you the employees who have at least one order in the sales orders table. You can achieve the same results using the exists predicate in the where clause. Let's see how to do that. Let's do select employee ID, last name, first name from HR employees, and let's call it E, where exists select star from sales orders table, where O dot employee ID equals E dot employee ID. Let's select this query and click on execute, and it returned the same results. The difference between these two queries is that in the first query, the subquery must count each occurrence of each employee ID found in the sales orders table, compare the count to 0 simply to indicate that the employee has associated orders. In the second query, exists returns true for an employee ID as soon as one has been found in the sales orders table, so a complete accounting of each occurrence is not necessary. Another useful application of exists is negating it with not. Let's see a quick example. Let's open a new query, and let's say select the customer ID and the company name from sales.customers table, and let's give it a table alias of C, where not exists select star from sales orders table, where C dot customer ID equals o.customerID. Let's execute this query. Click on Execute. And the resulting set is all the customers that have never placed any orders. When a customer ID is found in the sales orders table, not exists evaluates to false and the evaluation is quickly completed. Now let's see what we need to consider when using exists predicate with subqueries. When using exists with subqueries, the keyword exists directly follows the where clause. No column names or other expressions need to precede it. And within the subquery following the exists, the select list only needs to contain asterisk. No rows are written by the subquery, so no columns need to be specified. For example, in this query, the exists predicate checks to see if there is at least one order in the sales orders table for each of the customers in the outer query. And if it evaluates to true, that customer ID and company information is displayed in the result set. In this example, all the customers that have never placed an order and do not have any rows in the sales orders table will be displayed in the result set. The select list in the inner query typically only uses an asterisk since no data will be returned. The inner query just needs to test if there are any rows in its results. It doesn't have to return the rows themselves. And since no rows are returned in the inner query, there is no need to specify the column names. Now let's see what we've learned so far in this module. We've learned what subqueries are and how to use them, how to write self-contained subqueries that return scalar or multi-valued results, how to write correlated subqueries in a select statement, how to rewrite some correlated subqueries as joins, how the exists predicate combines with the subquery, and how to write queries that use exists predicate in a where clause to test for the existence of qualifying rows. In the next module, you'll learn about table-valued functions, views, derived tables, and common table expressions.